someone did. I want to know the first thing, Adrian, that you did. What'd you do?
I combined my 6x
Plus 3x.
You combined 6x with what?
Negative 3x.
Okay. And then I heard, Jerry, was it you? What does that do? Or what do you get when you combine those two?
3x.
Good. A positive 3x, right? Because who's stronger, the positive guy or the negative guy? Yeah. So we subtract and keep the sign of the bigger dude. But then moving on, thank you, Adrian, thank you, Jerry. Who else finished one? I think it's finished. Did the second step. Trey, what'd you do?
Subtract 4.
Good. Subtract 4 from who?
5.
Got it. And 5 minus 4, Kayla, what'd you get? And that's a positive one, right? Ooh, because the 5's stronger, right? So you get a positive one or a plus 1. Now, my question, can you go any further? No, why not, Daniel? Yeah. The very, very proper term is they're not like terms. They're not like terms. One is an X and one's a number. One's an X and one's a number. I watched this study once. It was a TED Talk. I don't know if you guys ever heard of TED Talks, but
I heard good.
It's not like a guy's name, but I mean it is. TED Talks have to do with talks about basically education. But anyway, and someone was teaching their 5-year-old niece how to do algebra. And we were like, what? He was like, yeah, it's easy. For instance, he asked her, and she had known a little bit of addition. He was like, okay, so if you have 2 apples, you get 1 more apple. How many do you have? She's like, 3 apples to roll this. Okay, perfect. What if you have like 4 like Barbie dolls and another Barbie doll? Have 5 Barbie dolls, like perfect. So what if you have 2 X's and 1 other X? 3 X's, like she was doing algebra. Just because it's as simple as whenever you have like terms, you just combine them. You just put them together whenever you're adding or subtracting, right? But we can't take apples with oranges and combine them to be a single, or at least we shouldn't. If we start putting apples and oranges together, that's weird. So we keep them separate because they're not like terms. That's a thing. But why was number 2 a little bit harder as far as the operations? Just a little bit. Yeah, we have to do nice term too. We have to distribute, right? Because this -8 with a parenthesis means multiplication. True?
True.
So before we can ever do the addition, PEMDAS says parentheses. But are these like terms? Y minus 3?
No.
No, so we can't do anything in the parentheses. They're stuck apart. But we can do the multiplication next. And we would end up with, check your word, did you get -8y plus 24? Did you get -8y plus 24?
Yeah.
But we still had the plus 2y. We couldn't forget about him. But we're not done. Alexis, why aren't we done?
I got number 1 wrong.
Because we haven't put the y's together.
Good. We have y terms, right? Like with apples, like with oranges, we put them together. And we say, yeah, we can make this simple. So, -8y plus 2y ends up getting us what? Good, Andrew Bosch, because the 8 was stronger, and he's a negative sign, so that's what we keep when we take away from each other. 8 minus 2 is 6, keep the negative. But don't forget your 24. However, can we go any farther?
No.
No.
-6.
Huh? Are you keep factoring?
Yeah.
Oh, yeah? Nice, just not quite. Nice, but not quite yet. But can you guys go to try number 3? There's a new problem up on the board.
Added 8 to the 2. And then got 24 plus 10.
What sign is it? I also think of a number, yeah? I have my positive numbers going this way. I have my -3, 5, 6, 7. What does addition actually do, Alexis? Moves this way. So if we want to do -8 plus 2, we have to move in the positive direction on the number line, which lands us at -6. Now everything else that we know are shortcuts, but this is the main idea of adding and subtracting. Subtracting always goes on the left of a number, and addition always goes on the right. Does that kind of make sense? But the way my shortcut works is every time you add or subtract numbers, kind of like a battle, and either they're working on opposite sides or they're working on the same side. -8 and +2, opposite sides. So when they clash, they're going to take away from each other. Now, he's not very strong. He's going to win. But whenever they clash, some of his power is used. So number 3, what are you guys doing? Hopefully it has something to do with distribution, right?
Yeah.
Hopefully it has something with distribution. Now, usually I work through step by step to get the answer, but I'm curious if anyone's gotten the right answer. So before I take advice, before I take steps, thank you, my volunteers. You guys just double check if you got it right. Yeah. Did you get 3H plus 26?
No.
Yeah.
Yes.
No.
Yeah. What? No. Yes.
Don't worry. We're going to figure out how to do it right now.
I mean, yes.
But if you got it, then let's see how you got it. Daniel, what's the first thing you did?
You distributed.
Distributed what, though? Okay, so Daniel distributed the 4 to the H first and got 4H and 4 to the 6, right? Did you get 24, Daniel?
Yeah.
Okay, now hold on. I need someone to tell me how to keep going. How to keep going. Jerry, what should we do next?
Combine the negative to the parentheses.
Okay, and actually we can use the word distribute because, wait, you multiply by a negative? Yeah. What's technically in front of a parenthesis if no coefficient's there? What's the understood? So we can think times, okay, good. So we get 4H plus 24 minus H. And then, hold on, what's a negative times a negative?
Positive.
Nice. Got him. Caleb, finish this off. You got it right, yeah? Okay, now what? So you combine the H terms. And then technically we still have the 24 and the 2, but what can we do to that? Andrew, what's up?
So that negative is just, so why is the negative?
It's tricky, right? Well, why did we do the 4? Because we had to. True? Because whenever you have parentheses, basically parentheses take ownership of something and say it's mine. So the H plus 6 are in those parentheses, it's mine, like it's trapped. And so whenever we take that entire lump and say times 4, I have to take that times 4 to each and every piece. It's called distribution, it's really multiplication, right? Okay. So what about the negative sign? It's mine. What are we doing to this lump or this expression? We're subtracting. But what are we subtracting? Well, we have to subtract each piece. Does that make sense?
Yeah.
We have to subtract each piece. Now, this is a silly example, and I'm not sure it's a great example, but I'm just going to try and use it. Ready? What if you got up to like a cash register? Let's say like today at lunch. You go over to buy some food from the snack shack, or whatever it's called, campus kitchen. You go to buy food from Bob. Okay. When you go to buy food, let's say they tell you the total, right? Let's say they told you that. Let's say they told you like, hey, you owe us like $3.50. Okay. Sure. Stop. Focus. You owe them $3.50 for whatever it is that you want to buy. Okay. What if you gave them a 5? Okay. What if you gave them a 5 and they just gave you $1 back?
That would be not fair.
Right, because they're supposed to take from your 5 the dollars and the cents and figure out how many dollars and cents you get back, right?
Yes.
You owed them dollars and cents, $3.50. I know it's all money, Andrew. Are you gonna get me? It's all money. It's all like a lump. But there was dollars and there was cents, and they needed to give you both of the change. You didn't just want the dollars. You wanted the dollar and the 50 cents. Does that make sense?
Yeah.
So when you're subtracting, you can't just, if it's a lump like this or if it's a combined, like my dollars and cents, even though this is H's and 2's, if I'm subtracting this whole thing, I have to make sure I consider both. Kind of cool? I have to consider both. You can't just do one and leave the other one out in the cold, or else, well, someone's not going to be happy. Either Bob's not getting his money, and that's not happy times, or you're not getting yours, and that's not happy times either.
Uh-oh.
Poor Bob. Okay. That was the warm-up for today, but you guys, if you're already in your notes, just stay there. And if you're not in your notes, we'll get there because, ready? We're going to talk about, basically, what it was that we just did and what the vocab is to explain each of those pieces. we're learning in this chapter, chapter 7, about polynomials. That's the snazzy term, polynomials. We're building up to one of the most important things you learn in Algebra 1, the second half, aka Algebra 1B. We're building up, but don't worry, we have like days and sections, and we probably have a test before we even get to the really important thing that you learn. We're building up to what we call factoring. So Isaiah, it's actually super cool that you brought that up today. But we just have to get the terminology right. We just have to get the terminology right. Now, there are a couple down here that I didn't fill in yet because I wanted to make them division. Let me give you guys just some time to write what you see. Now, there were just a few of you that aren't writing down all the notes that we take, and it does hurt you on homework, and it hurts you on studying. So I made a quick note, too, if I was like, ooh, I'm seeing some things missing. Make sure you get them down. Monomial.
Circle.
Don't worry, we'll get there. Oh, some of you are already trying to think about what to do, right?
Yes.
A monomial is basically a lump of numbers or variables or, hold on, isn't this a math term? What's product mean? No, I was thinking of math. Product. What's product mean? Multiply. Good. So either it shows multiplication. I didn't have room to write multiplication, so I just wrote multiply. But a monomial says, hey, it's a number. Oh, that's a monomial? A number? Like 3? Yeah, it's a number. It's a variable. Oh, like 2x? Yep. Or a product, a multiplication of numbers and variables. But do you guys see what I've written right here? No addition or subtraction is legal in what we call an expression. So a monomial is an expression that has numbers or variables or multiplication. You help me on that. Multiplication of numbers and variables. With no addition or subtraction. No addition or subtraction. So I'm going to show one down here. I'm actually going to show 2 more. Let's go ahead and do something like 5x over y. And let's show 5x over 2. So, if monomials, and if you want to think about it, technically, I don't know if you've ever talked about prefixes in English. But prefixes are going to be really helpful in what we're learning with the vocabulary. Because monomial means 1. Yeah, exactly. Monomial means 1. And the nomial, mono, 1, and the nomial, 1 term. Now we're learning what a term is by figuring out what a monomial is. And that's going to help us because then we're going to learn something called a binomial that has 2 terms. Or a trinomial that has 3 terms. And a polynomial. You guys ever heard of a triangle or a quadrilateral or a
I heard of a triangle before.
pentagon or a hexagon, heptagon, octagon, nonagon, dodecagon? That one has 12.
I've never heard of that.
But maybe you haven't heard of all those crazy names. Maybe you've just heard of a polygon.
I heard of a triangle.
Triangle has how many sides?
3.
Polygon has, I don't know, many. Trinomial has how many terms?
3.
Polynomial has many. But wait. Where's the monomial? Monomial has 1 term. Okay. Has anybody found a 1-term expression below? There can be more than 1. See? Yeah. So here's a monomial. No. It has numbers and variables multiplied together. Exactly. It has numbers. Yeah, it has 100. And variables. Yeah, it has x. Technically, x times x has lots of variables, or x squared. But 100 and x squared, no more airplanes. One term, monomial, check. What's another monomial?
E.
E? Ooh. That one's so much more complicated, and yet, isn't it just numbers and variables multiplied together? Sweet. Monomial, check. Monomial, check. Is there another one?
D. No, no.
Why not D? Has addition and subtraction.
subtraction.
And I can't put it any more together. I can't condense it any further. X squared is different than X. That's like an apple, that's like an orange. They're both fruit. They both have X's, but they're not the same. The addition and subtraction, and I can't condense anymore. What's another one that I could say no to? B, yeah. There's actually one more no and two yeses.
A.
A is what?
No. Yes.
Do you see it? I can have just a number. I can have just a variable, or I can have them together. So this is actually a monomial. I can have just a number. It's one term. So now here's the question. Who is and who isn't? Because they look so alike. Andrew.
F is
F is yes or no?
no.
Good. And G is yes. Okay, now hold on. This one looks really weird. That's why I gave you these two. Do you see how this only says product of numbers and variables? What would this be called? Of variables? Do you remember? It's division, it's not a product. Yeah, it's because of the y being in the denominator. It's actually called a quotient. Now, some of you are like, well, if that's a quotient too. Huh? What if there was a 6 on top? If there were 6 x's and we were cutting them in half, dividing by 2 is cutting in half, right? Yeah. If there was a 6 on top, couldn't I cut 6 in half and say, oh, there are 3 of them? So why don't you like this one? It's because 2 doesn't go in evenly, but can't I rewrite this as a number times a variable? The same way if it was 6, I would have divided by 2 and gotten 3. 5, I'm going to divide by 2. It's just not nice. It's not pretty. It's not easy on my head. But technically, I can cut those 5 x's in half. It's 5 halves times. I can rewrite it to be my monomial. So since I can rewrite it, well, that's okay. But if I try to rewrite this one, 5 over y, that's still not a number. I have a variable over a variable. A quotient of variables is a no. A quotient of variables is a no. A quotient of numbers is actually going to be okay as a yes. So far, all we've learned is, the warm-up says, I think combining my terms is important, and then we've learned the word monomial. That means how many terms?
1.
But what's a term? A number, a variable, or a multiplication of numbers and variables, right?
Yes.
Okay, so keep going. If we're looking at what we call a monomial, there's an adjective. If you guys are English, you pull it up. There's an adjective, something that describes monomials called degree. Maybe I should call it an adjective. Doesn't really describe it. It does, but not in a normal way. Like it's a cat. What kind of cat? A black cat. Okay, adjective. Let me put it this way. It's a, let me get rid of this. It's a characteristic. Maybe I shouldn't use the word adjective because it's not like a describing word, but it is a characteristic. It is a characteristic. Kind of like, ready? If I was talking about a car, I had someone yesterday who, she owns like a Toyota Tacoma truck. She's a friend / old student. She's very proud of her truck. She loves to go like motocross racing. She used to be in the pros when she was like in middle school and younger high school. Now she's trying to go to med school, so she's in college and all that stuff. But she loves her truck. She just got it. She can throw her motorbike in it. Super proud of it. She took a snap story, zooming in on a Prius, and she was like, "What?" She's like, "My truck has a V6 engine. This little Prius had a V8." She's like, "My truck is a 2x2. I know, kind of sad, but she goes on her motorbike if she's going off-roading. Like, my truck is a 2x2. This Prius was a 4x4. And her truck is gas, and this Prius is diesel. And She's like, what's going on with the Prius? Anyway, all that to say, that's why the example popped into my head. Degree to monomial is like horsepower to a car. Is a car just horsepower? No, not at all. But is that a part of what it is?
Yeah.
Does that describe it partially? Yeah, it's one of its characteristics, one of its specs, right? One of its key details that you care about. That's what degree is to monomial. Or, we live in California. Aren't earthquakes a thing? Sadly. And especially for you guys, because we had, like, what? Those ridge crest ones, like 2 or 3 big ones that we felt recently. Horsepower to a car is like degree to monomial, and magnitude to an earthquake is like degree to a monomial. What's an earthquake's magnitude?
7.5.
Yeah, and what are those numbers? You don't tell me the science of what they mean, but in general, what do those numbers kind of describe? How big it is, right? How strong it is. Okay, so guess what degree is talking about of a monomial? Horsepower to a car, magnitude to an earthquake, degree to a polynomial. We're going to learn what it is, but basically it's how strong the monomial is. Basically, how strong the monomial is. Basically. And to be honest, guys, hold on, check it. Degree has to do with, can you guys, like, if you have a highlighter or a color pen, can you make a big note of exponents? It's not the numbers in front. It's not the coefficient that actually does not determine how strong a monomial is. It's not the numbers in front. This one has a half, and this one has a 5, but this negative a half and this 5, it's not, those don't tell us the degree. Those don't tell us the strength. What does are the exponents, and not just, well, this guy, doesn't he have more than one exponent? Because what's y's exponent, guys? Okay, can you remember the exponent rules? What's x's exponent? 1, remember, understood 1? So what do you do if you have more than one? Because we just saw, Andrew Bosch, you were the one that called it out, that weird monomial on the page before. Wasn't there one that had lots of variables? So if I just say exponents, you're like, which one? And that's not the question. What does this say about exponents? What are we supposed to be doing for degree? Not which one, but another mouth word. What's sum mean? Add up. Right? So I'm looking at the exponents for the power, the degree, the strength of the monomial. And I'm not just looking at one exponent, I'm looking at them all. And I'm adding them, right? Let's do that. So check it. Now wait. But exponents of who? Or of what? Only of, maybe we should underline that last word. Okay, fine. All the words are important. But it's the sum of all the exponents of all the variables. So, let's see how we do. Ready?
Yes.
Are these too small? Can you see them?
Yeah.
My first one is 5x squared. How many exponents, or what exponents do I have with variables? 2. Just the 2. That's it. So guess what? The degree is just 2. Wait. That's it? Maybe homework won't be too bad. Woo! Part of it. We're just learning ideas. We're not necessarily doing tons of work. We're learning ideas. So the degree is 2. Well, what about the 5? No. I'm looking at exponents. What about the 5's exponent? Doesn't the 5 have a 1? Oh, but he's not a variable. Okay. So then for letter B, we don't worry about the 5 at all, him or his exponent, because we're looking at the exponents of variables only. So, Jeremy, for letter B, if we're supposed to add together all the exponents, all the variables, what do you think the degree would be for letter B? Woo! You guys agree?
Yeah.
One.
Is that a 1?
Yeah. It actually, Jerry, just so that you're ready for real problems, it was nothing. But we talked about nothing means an understood 1 when you have right? A variable. So I wrote that little 1 earlier when I was talking about this, but I didn't talk about it right now. But yeah, it's x to the 1 and y to the 3, and so 1 plus 3 is 4. The 1/2 didn't matter. The negative didn't matter. So we have the variables and the exponents, and that's it. So, because we're only looking at variables. So all we had was the 2. Okay, so now, looking at letter C, think about the 8, the x cubed, the y cubed. Levi.
Oh, let's go, Levi.
Got him. Do you guys agree?
Yeah.
The 8 didn't matter. The 8 to the first power didn't matter. I don't even care if it was 8 to the 10th power. It doesn't matter. The 2 variables were x and y, and each of their exponents added together were 6. Now, letter D. This one's a party. So I'm not gonna pick on someone for this one. I'm gonna choose a volunteer who thinks they know it, because it's a tricky one.
Number 1. Agree is 1.
I saw your hands about the same time.
0.
Adrian's so excited. His
0.
chair's off the ground. What do you think, Adrian? 0. Woo! What do you guys think? Woo! I heard 0 and I heard 1.
1.
0.
Cat.
1.
There is no.
0.5.
Question. Which one makes sense? You ready?
0.
Does negative 3 times x to the 1 make sense, or does negative 3 times x to the 0 make sense? Which one would get? Which one's the same? There's no variable. Does that make sense?
No.
Because there isn't a variable.
0.
Good. If it was x to the 1, the x should still be there. But it's not. If it was x to the 1, if the degree was 1, the x should be there, and he's not. What happens when I raise anything to the 0 power? It's 1. Oh, it's gone! Oh, God. So we learned the word monomial, 1 term. We learned the word degree. Now okay. Ready? We have one more page of vocab. One more page of vocab. Now hold on. This isn't supposed to be crazy, like earth-shattering, super hard. Because mono meant 1 term. Poly, you can talk about polytheism, you can talk about polygon, you can talk about. Isn't there some disease that has poly? I can't remember what it's called. Polio? No. But that's a good idea. No, not polio though.
Leprosy.
Polycystic. Not cystic fibrosis, but it's hard to that. Anyway, that's okay. Polynomials, ready? This means many terms.
Why is your pen?
Polynomials, many terms. Or, actually, if you look at it, now, polygon has many sides, but polytheism, you have many gods or many different religions coming together. Polynomials, many terms, but if you guys look at the actual definition, I need to be really careful with something. Yes, this says many, but look, a monomial is still a polynomial, which is weird. Poly does mean many, but actually monomial kind of sneaks in under that name. So polynomial is like the big name for everybody. Guess what? A square is a polygon. A triangle is a polygon. A pentagon is a polygon. An octagon is a polygon. For polygons, which are shapes, poly includes them all. For polynomials, it includes them all. So it includes monomial, but then it also includes the guys who are additions or subtractions of monomials, but they have special names because a monomial is only allowed to be 1 term. So as soon as we start writing ones with more than 1 term, like from the page before when we had that addition, or when we had some addition and subtraction, there are names for them. It's just not monomial anymore. Now these are all polynomials. Polynomial is the big overarching umbrella term, but monomial just has 1. Binomial has 2. Trinomial has 1, 2, 3. You guys see it? Whenever whenever you see an addition or subtraction for polynomials, it's dividing up terms. So do you see the 2 terms to be a binomial? Or do you see the 1, 2, 3 terms to be a trinomial? But we have to go beyond names. So we had the names, but then we had to talk about degree again. We've talked about the names, but now it's time to talk about degree. So polynomials, all of a sudden we can have addition and subtraction, just the names are going to change. Polynomials, all of a sudden we can have addition or subtraction, but we just have new names because they have more than one term. But we also have to revisit degree. So degree, still strength, still power, still magnitude, horsepower of the polynomial. But now all of a sudden we're going to have competitors. If there's addition or subtraction, we're going to have competitors. Andrew, we're going to have competitors.
I'm just trying to guess.
So here's the deal, guys. If you have competitors, ready? If you have competitors, and if we're trying to talk about power or strength, what I need you guys to remember is the strong one wins.
Always.
That makes sense,
Yes.
right? That makes sense. Now, yes, I know in fights there's like, oh, who's stronger, and maybe like the little scrappy one somehow comes out on top. But coming back. Just in general, the stronger one wins. So down here, when I say degree, not just of a monomial, but of a polynomial, we're going to need to have the competitors, each of the terms, compete and to basically ask ourselves the question, who's the strongest? Whoever the strongest one is going to be the winner. Who's the strongest? Who's the strongest? He's going to be the winner. He's going to be the winner because the strongest degree is the one that we use. When we're looking at a polynomial, the strongest degree is the one that we use. So can I come up here to this trinomial? There are 3 different terms. All 3 are competing for basically ownership of the whole thing. All 3 are competing for ownership of the whole thing. I will say the ownership is winning the degree spot, determining the degree. Okay? So we have this degree competing that, or this term competing that term, competing that term, competing for who gets to choose the degree. Well, the key is who's strongest. Well, kiddos, we have to think about each of them. What's the degree of this guy? Do you remember from what we just saw a second ago? What's the degree of any number if there's no x?
1.
No, not 1.
0.
What's the degree of this guy? 1. And what's the degree of this guy? So guess whose degree gets to go in the blank? Yeah. Kind of like if you're at a law firm, isn't like the boss's name the one on the wall usually? Right? But there's all these different workers. But who determines the name of the boss? That's kind of like this. Who determines the degree? Oh, the strongest one. So the very last thing we have to talk about is this thing called standard form that says you go in order from strongest to weakest as far as degree. Alright guys, we have a whole nother minute, I think. Can we just peek at a couple more homework type problems? Let's see what else we're going to see. We're supposed to rewrite these guys in standard form, figure out the degree, and the leading coefficient. I thought coefficient was like a number. Okay? We're trying to figure out the standard form. We're trying to figure out the degree. And we're trying to figure out the leading coefficient, otherwise known as the leading number. So, does it make sense for this first one? I'm going to rewrite him, and I'm supposed to go in descending order as negative 9z plus 4. I need the strongest guy, the strongest variable guy in front. And this one, isn't the strongest variable guy the cube? Now, you might make some mistakes on signs. It's kind of tricky to know what goes with
Who?
With the cube, the square, the T. Hold on, pause. After we write in standard form, I'm just going to go quick. You can take a picture of it on the way out the door. We would have to figure out the strongest guy's degree, and then the leading or the first coefficient. Take a picture of it on the way out the door. That's the end of your homework. And let's see how you guys do for tomorrow. Bye, guys. Binomial. Oh, thanks, Adrian. You really mixed it up. There we go. Get the vocab down. Get the vocab down. It'll be not too bad. Too much fun. Bye, guys. See you guys later.